All right, this is Mr. Smith here. This is Algebra 2, and we're working on trigonometric functions, specifically their inverses. Now, for those of you who have been through geometry, at least at this high school, you have seen a few problems of how to take inverses. And so let me clear this off. I apologize. All right. And so I'm actually going to start here with a problem that should resemble something that you would have seen in geometry. Okay. So if I want to find what the actual measure of theta is there, I need to use the trig function that talks about the opposite side over the hypotenuse. And so that trig function is sine. All right, so sine of theta equals opposite over hypotenuse. And my goal is to get theta by itself. I want to know what is the angle measure. And so the way I do that is I use sine inverse. Okay, if I want to find out what an angle actual value is, how many degrees is it, how many radians is it, I'm going to use a trig inverse function to do that. So, and you may not have been shown this before, but how do I get rid of the sine? Right, that's really the question, because I want to have it say theta equals something, 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 so I need to get rid of the sine, and the way that we do that is by taking sine inverse on both sides. So sine inverse is not any trig function that we've seen this far. Sine inverse is its own function. And I take sine inverse on both sides. So whatever I do to one side, I do to the other. And now here's the next idea, and that is that when I take sine inverse of sine, they cancel out. And when I take sine inverse of sine, it cancels out. The same way that if I take a square root of something being squared, those cancel out. Okay? And so what happens on the left side is we're left with just theta, and on the right side we're left with sine inverse of 5/13. And this, your calculator will handle. Right? So on our calculators, we should just be able to go to the trig window, sine inverse. So again, here's the trig window. There's the button. Now I just type 5/13. And there we are, 22.6 degrees. Again, make sure that your calculator is in degree mode. And there we are, 22.6 degrees. Okay, so this angle for this triangle, if this side length is truly 5 and this side length is truly 13, then it must have a theta, it must have this angle being 22.6 degrees. All right, let me show this type of problem again. We'll go a little quicker this time. So here they ask us to find this theta, and so the first thing we have to do is identify what trig function should I be talking about. So we have the adjacent side, and we have the hypotenuse. So that would be cosine of theta equals adjacent over hypotenuse. So to find out what theta equals, I'm going to take cosine inverse on both sides. So theta equals cosine inverse of 6/11. And now again, we can go right to our calculators. Our calculators can calculate this. And we go cosine inverse 6 divided by 11. And that is 56.9. We'll call it 57 degrees. Okay. So you should probably give me 1 or 2 decimal places. In this case, rounding at 1 decimal place gets me up to 57. All right, so at this point, I've handed out a unit circle to all my students, and I have a copy here. And the unit circle is a memory tool to help us learn some of our basic trig functions and their values. So in this chart, you can see 30 degrees, and now you have a coordinate radical 3/2, 1/2. The x value is the cosine of 30. The y value is the sine value of 30. So if I asked you, what is sine of 30, you could come onto the unit circle, you come over to the y piece, and sine of 30 is 1/2. If I ask you, what is sine of 90, we come up to 90 degrees, and it's the y value, so it is 1. Okay. If I ask you for cosine of 135 degrees, cosine is the x piece, so it is negative radical 2 over 2. Okay. If I ask you for sine of pi radians, sine of pi radians, that's the y piece here, so it's 0. Okay, so this is a tool to help students learn some of the most foundational trig values. Okay. In pre-calculus, you'll have to memorize this. So if I were to ask you, for instance, sine of some value, actually let's do cosine. No, I changed my mind again. Back to sine. So sine of some value, theta, equals 1. And I want to know, what is that theta? The way I can do it is I can look around the entire unit circle. I can look around the entire unit circle and find the angle measure that gives me a sine value or a y value of 1. Okay, so as I look around this unit circle, I see I can go around and around and around until here the y value is 1. And so theta in this case must be 90 degrees. So if I want to think about it this way, theta equals sine inverse of 1, which is 90 degrees or pi over 2 radians. Okay. Let's look at another problem. Let's do cosine of some theta. Cosine of theta equals 1/2. And that's the same idea as me saying that theta equals cosine inverse of 1/2. And so again, I'm asking for what angle measurement gives me a cosine value of 1/2. So I'm gonna go around the unit circle. If you're watching the video, jump back to the unit circle, and I'm gonna look for an x value that's 1/2. And I see that happens where? I see it happens at 60, and it also happens at 300. Okay, so it happens at 60, so this equals 60, and we also get a value that equals 300. Okay, but which one do we use? Okay, so this is a problem, because I know that when I have one input value, I should only get one output value for it to be a function. So to make cosine inverse a function, we have to restrict the domain so that I don't get two values out. Let me say that again. I want cosine inverse to be a function, but it just gave me two values out when I plugged in 1/2. So to modify it, I'm going to restrict the domain so that when you punch in your calculator cosine inverse of 1/2, it's only going to give you out 60, even though there's a second answer. For real. So what we do, and this chart shows it, is we restrict the domain. You don't need to necessarily memorize this. You just need to understand why your calculator is only giving you one value out. Okay? When you punch in cosine inverse of 1/2, your calculator will only give you one value out, namely 60, even though there are two values that it could give out. The reason it does that is because we restrict the domain of the inverse functions. Okay, so inverse sine, we only look at between negative 90 and 90. Inverse cosine, we look between 0 and 180. And inverse tangent, we look between negative 90 and 90 again. Okay, and so anytime we take inverse functions, it has this restricted domain so that we only get one value out. Okay, let me show you this in application. Again, you don't need to memorize this. You just need to have some understanding of why we're only getting one value out from the calculators. So for instance, cosine inverse of radical 3 over 2. And again, this would be the same as saying, if I took cosine of some theta, some angle, I would get out radical 3 over 2. And the question is, well, what theta does that? Okay. Now remember, we're only going to talk about one of the values, even though there are two. So what angle measurement? So look on your unit circle. Look on your unit circle. Which angle measurement gives us a cosine value or an x value of radical 3 over 2? 30 degrees. So in this case, this is 30 degrees. How many radians is that? It's pi over 6 radians. Okay. This is the idea. And if you punch this into your calculator, if you type in cosine inverse radical 3 over 2, you will get out 30 degrees. Okay. And that's all they want here. That's all we're looking for. So finding inverse trig functions is easy as long as we stay in quadrant 1. As long as we stay in that first quadrant between 0 and 90 degrees, everything is pretty easy. It's as soon as we start to venture away from that that our work becomes a little bit more difficult. All right, sine inverse of 2. Here's the idea. Again, this means that there's sine of some theta, some angle, and that equals 2. Okay, now if you look on your unit circle, you're not going to see any y values that equal 2. In fact, if you look at all of the y values, they seem to go from -1 to 1. All of the y values are in the range from -1 to 1. There's no y values that are bigger than that. So how could I get a theta of, if I could plug in an angle and I get out a ratio of 2? Let me try to illustrate this a different way. Let's draw a triangle. Let's call this angle theta. So if this angle is theta, what do I know about this side length and this side length? This is a 2. That's a 1. And that's a problem. Because the hypotenuse always has to be bigger. So there is no angle that will ever make this true. And that's why sine has to be between -1 and 1. Because if sine were bigger than 1, I would get this setup where I get the side length was bigger than the hypotenuse. Okay. So for this reason, the answer to this question, what is sine inverse of -2? You could say it's undefined. You could say there's no solution. Because undefined or no solution are probably math terms to mean what you want. So no solution. There is no theta. There is no value that will ever do that. Okay. Yes. Right. So the question is, how is cosecant different than sine inverse? And so the easiest way to explain it might be that our sine values and our cosecant values are similar. They're reciprocals. And so our sine inverse values and our cosecant inverse values will be similar. They'll be reciprocals. Actually, let me think on that. It's not how I want to phrase it. So scratch that. They are different functions, and they do behave differently. Let me just generalize it like that for the time being. Okay. So now we're going to do tan inverse of negative radical 3. Now, tangent is not on the unit circle. When you look at the unit circle, tangent values are not here, except that we have this relationship that tangent is y over x. Right? Sine was y over r, cosine was x over r, tangent was y over x. And I happen to have an x and a y, so I can calculate tangent. But let me make your life a little bit easier. Let's just go through, let's just go through here, and we'll call this scratch work. And I asked you to do this on the quiz. Let's say this is 30. Let's say this is 60. This is 1, 2, radical 3. And if I ask you for tangent of 30, I have no idea why I just wrote 1, radical 2. Let's try that again. There we are. So if I ask you for tangent of 30, tangent should be opposite over adjacent. So tangent of 30 is 1 over radical 3. But when we rationalize the denominator, it becomes radical 3 over 3. Okay, so tangent of 30 is radical 3 over 3. And tangent of 60 is going to be, so tangent of 60 opposite, so radical 3 over 1. So tangent of 60 is radical 3. I'll tell you, I would write this down on my unit circle. These are going to be facts that you're going to want to have. Also, if you want to know tangent of 45, well, it should be y over x, but it's radical 2 over 2 divided by radical 2 over 2. So tangent of 45 is just 1. Yep, so let's go back. Make sure we get those down. Tangent of 60 is radical 3. Tangent of 30 is radical 3 over 3. And so now this is asking, when I take tangent of some angle, theta, I get negative radical 3. When I take tangent of some angle theta, I get negative radical 3. Okay, so if I plug in a 60 degrees here, that's not going to work because I know tangent of 60 is radical 3. And I want to get negative radical 3. So I can look to my unit circle to try to guide me a little bit. And the unit circle can be helpful that way. I should also come back a little bit to this knowledge to say, well, I know when I talk about the inverse tangent function, if I'm not in quadrant 1, then I got to be in quadrant 4. It's got to be one of these two places. And so the only other thing that I would tell you to help guide you through this problem in part C is that you can also use your calculator here. Right? And so maybe we rely on the calculator a little bit, and the answer is going to make sense when we see this. So tan inverse of negative radical 3. All right, so we go with our trig. Tan inverse negative square root of 3. And this is negative 60. Negative 60. And that, again, should seem reasonable because when I take tangent of 60, I get radical 3. So I take tangent of negative 60 and I get negative radical 3. Okay, so all these connections, there are lots of little connections here in our trig and our trig functions. Okay, so this theta here has to be negative 60. Okay. All right, so let's try to apply this now to a practice problem. Why don't you guys look, those of you who are watching the video and those of you who are in class, why don't you just try number 1 really quickly to make sure you are feeling comfortable with this material. Pause the video now, please. Okay. So as long as we are talking about an inverse function and we're in the quadrant 1 or we're in the quadrant where we're right, where it's defined, the problems are going to go very easily. But this is a problem where they want us to solve this equation, but they don't want us to give the value that's going to come out in quadrant 1. They want us to find the other angle. That's what they're saying there. Find me the angle that's in quadrant 3. Okay, so there's some angle that satisfies this equation, and that angle is somewhere over here. I'll call it theta. There's some angle theta, and I'll just draw it out. In this quadrant, quadrant 3, that satisfies this equation. That's the angle I want. I don't want the original one that we're going to get. Okay. That's idea number 1. Idea number 2, if I look at my unit circle, negative 5/8 is not a value you're going to find on the unit circle. Not anywhere. So it means we're not going to be able to rely on the unit circle. We're going to have to go right to our calculators. Okay, so let's do that. So to find theta, I'm going to take sine inverse on both sides, and I'm going to get theta equals sine inverse of negative 5/8. Sine inverse, so theta equals sine inverse of negative 5/8. So we go to our calculator, and we go, so let's go with our trig, sine inverse, sorry, I need to clear this out. To do trig, sine inverse, negative 5/8, and we get negative 38.68. To make our lives a little easier, let's call that negative 39. Okay. So in this case, theta equals negative 39. And let's go ahead and draw that out on our graph. So here, let's call this negative 39 degrees. Okay. So here's the problem. I know what angle, if I plug in negative 39 degrees into this equation, it'll work. The problem is, that's not the quadrant that we're looking for. I'm looking for an angle measure in another quadrant. And so I'm going to have to use my knowledge of reference angles, and I'm going to have to use my knowledge of reference angles the other way around this time. I kind of know what the reference angle is. Right? If this angle is 39 degrees, that means our reference angle from quadrant 1 will also be 39 degrees. Okay. The reference angle is always an angle between 0 and 90. It's always an angle between 0 and 90. And in quadrant 4, if I have an angle in quadrant 4, this difference between 360 and the angle is the reference angle. Okay, so 39 degrees. So I have the reference angle. What I don't have is the original angle, the big angle. Okay. So my angle theta is in quadrant 3. So think about it. How did I find reference angles in quadrant 3? What did I have to do? All right, theta prime, if I gave you the original angle, let's say the original angle is 210 degrees, what would the reference angle be? You minus 180, so the reference angle would be 30. Well, now I'm going the other way. I'm telling you the reference angle is 39, so the original angle had to be, so we're going to add 180, right? So I'm going to take 180 plus 39, and that's going to give us 219. 180 plus the reference angle. So here's 180. Here's 180 degrees from here to here. And then this is the little piece right here that gives us the 39. Right? So 180 plus the 39 gives me this whole big angle theta. All right, so it gives us this whole big angle theta. And now I have this angle, 219. So let me walk back through this process. Let me explain why we have to do this. And then let me verify this for you in the calculator, and then I'll take your questions. Number one, our calculators will only give us one of the values back. Right? We know that there should be two. The calculator only gives us one because that's what makes it a function, and we want it to be a function. Okay. That's idea number one. Idea number two. So we get this value here, and basically this is the reference angle. The reference angle becomes this number, and we're going to have to use it to find another angle that gives us the same values. Okay. So we're kind of working that whole reference angle piece backwards. Right? It used to be on the quiz, I asked you to find the reference angle. Now we're going to kind of have the reference angle, we're going to have to use it to find the other angles. That's idea number two. Now let me show that this actually works. So I'm going to pull up my calculator. Pull up the calculator. And I'm looking for some angle measure theta that equals, when I take sine of it, it equals negative 5/8. So negative 5/8. I see. Negative 5/8 is negative 0.625. And so when I take sine of 219 degrees, that should be very close to negative 0.625. Now it's going to be slightly off because I rounded 39. Remember when I rounded 39, it wasn't 39 really, it was, you can see it right here, it was 38.6. So because I rounded, our numbers are going to be off a little, but you're going to see I'm supposed to get negative 0.625, and I get negative 0.629. So pretty dang close. Okay? So this is the idea. I'm going to pick up with this lesson tomorrow at this point because I realize this problem is hard. So I want to look at a couple more examples like this. However, you can start on the homework tonight. It's not assigned, but you can start on it tonight so that you feel more comfortable when you come in for tomorrow's lesson. The homework for 13.4 will be due on Thursday. Thanks for your attention. This concludes part 1